Hello everyone, welcome to the lecture session on elements of mechanical engineering. I am Anil Kumar M M, working as an assistant professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. Today we are going to discuss the module 2. It consists of the turbines, pumps and then the boilers. In the previous module we have discussed about the energy resources and various energy harvesting techniques and the basic concept of the steam, concept of the thermodynamics and then the properties and formation of the steam. Okay. In today's session I am going to discuss about the turbines. Before going to know about the turbines, first let us know what I mean by the prime mover. The prime mover, it is nothing but it is a device which converts the natural available sources of energy into mechanical energy or mechanical work. Okay, that device we can call it as the prime mover. Prime mover, it is nothing but it is a device which converts the available natural sources of energy into mechanical energy or mechanical work. The natural available sources of energy is nothing but either it may be wind or hydro energy. That energy can be converted into mechanical energy. For conversion we are using one device. That device we can call it as the prime mover. Whatever the energy is produced from the prime mover, that can be used to run the generator, we can produce electricity, or that mechanical energy can be used to drive the pump or to drive the compressor, or we can drive the propeller of the ship. Okay, whatever the energy produced from the prime mover, that can be used to drive the electrical generator and we can produce the electricity. Okay, and this prime mover, it is classified into two types. One is the thermal prime mover and another one is the hydraulic prime mover. Okay, thermal prime mover, thermal is nothing but heat. This thermal prime mover, it is a prime mover. It converts that heat energy into mechanical energy. Okay, that's called as thermal prime mover. Hydraulic prime mover. Hydraulic prime mover is nothing but it converts that water energy into mechanical energy. Water energy is nothing but the water possesses both potential as well as the kinetic energy. That energy can be converted into mechanical energy. So for that the hydraulic prime movers are used. So example for the thermal prime mover, that is the gas turbine and then the steam turbine, and example for the hydraulic prime mover, that is the water turbine. Okay, so the prime mover nothing but it is a device which converts that available natural sources of energy into mechanical energy, and that mechanical energy can be used to drive the pump or generator or compressor or the propeller. And this prime mover is classified into two types. One is a thermal prime mover and hydraulic prime mover. Thermal prime mover, it converts that heat energy into mechanical energy. The hydraulic prime mover, it converts hydro energy into mechanical energy, and these are the example for the thermal prime mover, that is gas turbine and steam turbine, and water turbine is the example for the hydraulic prime mover. Okay. Next, coming to the turbine. What do you mean by turbine? Turbine, it is a prime mover. Okay, example for the prime mover is, that is IC engines and then the turbines. Turbine, it is a prime mover. Okay, it consists of the series of curved blades will be fixed on the circumference of the wheel. Okay, and this converts that the one form of energy into mechanical energy, and that energy can be used to drive the generator and we can produce the electricity. Okay, this turbine, it consists of the series of curved blades. Okay, these are the curved blades that will be fixed on the circumference of the single wheel, and this wheel we can call it as the rotor, and this rotor is connected to the shaft, and this shaft is in turn connected to the electrical generator. We can run the generator, we can produce the electricity. Okay, so turbine is nothing but it consists of this number of curved blades is fixed on the circumference of the single wheel, and that wheel we can call it as the rotor, and this rotor is connected to the shaft, and this shaft is connected to the electrical generator. Okay, and this turbine, it is classified into three types. Okay, based on the working medium used in the turbine, it is classified into three types. One is the water turbine, another one is the gas turbine, and then the steam turbine. Okay, based on the working medium which we are going to use to run the turbine. So based on that, it can be classified into three types. One is water, gas and steam turbine. Okay, water turbine is nothing but it converts that water energy into mechanical energy, that is called as water turbine. Gas turbine, nothing but it converts the heat energy of the hot gases into mechanical energy. Hot gases, that is produced by the combustion of the fuel. Okay, it carries that heat energy. That heat energy of the hot gases is converted into mechanical energy, that is called as gas turbine. Steam turbine, nothing but the heat energy of the steam that can be used to run the turbine and it converted into mechanical energy, that is called as steam turbine. Okay, but in your syllabus point of view, they are mentioned only the water turbine. Now let us discuss how the water turbine and what do you mean by the water turbine and what are the classification of the water turbine and what are the types of water turbine. Okay, now let us discuss what is water turbine. Water turbine, it is a hydraulic prime mover. The water turbine, it is a hydraulic prime mover. It converts that water energy into mechanical energy. Okay, water energy method, the water, it possesses both kinetic and potential energy. The water possesses both the potential as well as the kinetic energy. That energy can be converted into mechanical energy. Okay, and that mechanical energy can be used to drive the generator and we can produce the electricity. For producing the electricity, we are using the water power plant. In the previous module, we have discussed how the water power plant works and how to generate the electricity by using the water power plant. Okay, next coming to the classification. The water turbine, it is classified into various types. Okay, first one, according to the energy available at the inlet of the turbine. Okay, first classification according to the energy available at the inlet of the turbine. Okay, it is classified into two types. One is the impulse turbine and other one is the reaction turbine. Okay, what do I mean by impulse turbine? In the impulse turbine, only the kinetic energy is available at the inlet of the turbine. Only the kinetic energy is available at the inlet of the turbine. The turbine is called as impulse turbine. Impulse turbine, that means only the impulsive force is acting on the curved blades. Okay, that means the high velocity jet of water, when it strikes the curved blades, at that time the impulsive force is acting. So only the kinetic energy is available at the inlet of the turbine, that is called as impulse turbine. Example for the impulse turbine, that is the Pelton wheel. Next classification, next type of turbine, it is reaction turbine. In that reaction turbine, both potential energy and the kinetic energy is available at the inlet of the turbine, that is called as reaction turbine. In that reaction turbine, both impulsive and the reactive force is acting on the curved blades. Okay, that force, it pushes the blades to rotate. At that time, that energy is converted into mechanical work. Okay, so in the reaction turbine, both potential and kinetic energy is available at the inlet of the turbine, that is called as reaction turbine. Example for the reaction turbine, that is the Francis and Kaplan turbine. Okay, next classification according to the direction of water flow over the blades. Just you have to imagine this is a turbine and these are the curved blades that will be fixed on the circumference of that wheel. Okay, this is called as a rotor and this one you can call it as the shaft. Okay. Next classification according to the direction of the flow of water over the runner blades. How the water striking the runner blades. Okay, first one, that is a tangential flow turbine. Tangential flow is nothing but the water striking the runner blades in the tangential direction. The water flows tangentially over the runner blades. Okay, hence it is named as tangential flow water turbine. The water striking the runner blades in the tangential direction. When it strikes in the tangential direction, at that time it pushes the blades to rotate. So the blade starts rotating. So the kinetic energy of that water get converted into mechanical energy due to rotation of the rotor. Okay, example for the tangential flow turbine, that is the Pelton wheel. Okay, next, that is the radial flow turbine. The water striking the runner blades in the radial direction. That means it is perpendicular to the axis of the rotation of the runner. Okay, water flows over the runner blades perpendicular to the axis of the rotation of the runner. Okay, that is called as radial flow turbine. The water strikes the runner blades in the radial direction. Example for the radial flow turbine, that is the Francis turbine. Next, axial flow turbine. The water strikes the runner blades in the axial direction. That means parallel to the axis of the rotation of the runner. Okay, parallel to that axis of the rotation of the runner, the water strikes the runner blades. Okay, that type of turbine you can call it as axial flow turbine. The water strikes the runner blades in the axial direction. Axial direction nothing but it is parallel to the axis of the rotation. Example for the axial flow turbine, that is the Kaplan turbine. Next, coming to the another classification according to the head available at the inlet of the turbine. Head is nothing but that is the height. Okay, according to that head available at the inlet of the turbine, it is classified into three types. One is low head turbine, medium head turbine and high head turbine. What do I mean by low head turbine? That head available at the inlet of the turbine is less than 30 meters. That type of turbine you can call it as low head turbine. Okay, that means height available of the inlet is less than 30 meters. Okay, that is the low head turbine. Example for the low head turbine, that is the Kaplan turbine. And medium head turbine, the head available at the inlet is around 50 to 150 meters. Okay, that type of turbine you can call it as the medium head turbine. And next, the high head turbine, the head available at the inlet of the turbine is greater than 150 meters. That type of turbine you can call it as the high head turbine. Example for the high head turbine, that is the Pelton mill. That means height available at the inlet of the turbine, the water falling from the resources to the turbine blades. Okay, that height is, you can call it as the head. Okay, according to the head available inlet of the turbine, it is classified into three types. One is low head turbine, medium head and high head. Low head turbine, that is less than 30 meters height, medium head, that is 50 to 150 meters height, and high head, that is greater than 150 meters height. Okay, low head turbine example, that is the Kaplan turbine, medium head, that is a Francis turbine, and high head, that is a Pelton mill. Okay, now I'll summarize that the turbine, it is nothing but it is a prime mover. It consists of the series of curved blades that will be fixed on the circumference of the single wheel. Means these are the curved blades that will be fixed on the circumference of that wheel. Okay, and this that wheel we can call it as the rotor, and this rotor is connected to the shaft. Okay, and it is used to convert that one form of energy into mechanical energy. And based on the working medium used, this turbine is classified into three types, that is water, gas, and then the steam turbine. The water turbine is nothing but it converts that water energy into mechanical energy. So the water turbines are used, and the water turbines are classified into various types. One is according to the energy available at the inlet, and according to the direction of the flow of water over the runner blades, and according to the head available at the inlet. Okay, based on that, the water turbines are classified into these types. Okay. Now I will explain the working principle of the Pelton wheel, Francis turbine, and then the Kaplan turbine. Okay. Now let us discuss one by one. The first one, that is the Pelton wheel. The Pelton wheel, it is a tangential flow, high head, impulse water turbine. Okay. Tangential flow is nothing but the water strikes the runner blades into the tangential direction. The water strikes the runner blades in the tangential direction. Hence it is named as, it is a tangential flow. Impulse, only the impulsive force is acting on the blades. Okay, the impulsive force is acting on the blades, so that's why it is a impulse water turbine, and it requires the high head. Okay, it is a high head turbine. Okay, the head available at the inlet is greater than 150 meters. Okay, so the Pelton wheel, it is a tangential flow, high head, impulse water turbine. Okay, and it requires the small quantity of water is used to run the turbine. Okay, the construction, it consists of the nozzle with the spearhead. Okay, this is the nozzle with the spearhead, and then the runner with the buckets, and then the casing. Okay, these are the main components used in the Pelton wheel. Okay, first one, the nozzle with the spearhead. Okay, nozzle, it is nothing but it is the passage having various cross sectional area. Okay, now that is called as the nozzle that will be attached to the penstock. Okay, penstock is nothing but it is a pipeline that connects the water resources to the turbine casing. Okay, so the nozzle is attached to the penstock. In that nozzle, the small needle will be provided. That means that is called as the spearhead to control the flow rate of the water. Okay, to control the flow rate of that water, the small needle will be attached to the nozzle. Okay, and this needle will be operated with the help of the hand wheel. Okay, next coming to the runner and then the bucket. Runner is nothing but it is a circular wheel. Okay, and the number of evenly spaced buckets will be attached to the circumference of that wheel. You can call it as the runner. Okay, these are the buckets. The bucket is nothing but there is a cup shape. That will be buckets will be attached to the circumference of the single wheel. We can call it as the runner, and this runner is connected to the shaft, and this shaft is connected to the electrical generator. Next, casing. Casing is nothing but it's like a cover. The entire Pelton wheel turbine, it can be placed inside the casing. Okay, and the function of the casing is it helps to prevent the flushing of the water from the turbine. Okay, and also it is used to discharge the water from the turbine to the tail race. Okay, these are the main components used in the Pelton wheel. Okay, one is the nozzle, and runner and with the buckets, and then the casing. Nozzle nothing but it is a passage through which the water is flowing and enters into the turbine blades. Okay, in that nozzle it is connected to the penstock, and in that nozzle the small needle will be provided to control the flow rate of that water, and this needle will be operated with the help of the hand wheel. Okay, and then rotor is nothing but it is a circular wheel, and the number of evenly spaced buckets will be attached to the circumference of the wheel. You can call it as the rotor, and this rotor is connected to the shaft. Okay, and the entire turbine can be placed inside the casing. Casing is nothing but it is the cover. Okay, the entire the turbine is placed inside the casing. Okay, and this casing it prevents the flushing of the water from the turbine, and also helps to discharge the water into the tail race. Coming to the working, initially the water from the reservoir that will be enters into the nozzle through the penstock. Initially the water stored in a reservoir having high potential energy, so that water enters into the nozzle through the penstock. In that nozzle, the potential energy of the water get converted into kinetic energy. Okay, in that nozzle, the main function of the nozzle means it reduces the pressure and increases the velocity. So the high velocity jet of water will be coming out from the nozzle. Here, the potential energy get converted into kinetic energy. That high velocity jet of water is made to flow over the turbine blades. Okay, here the blades are in a hemispherical shape. That high velocity jet of water, when it strikes the turbine blades, this blade starts rotating because the impulsive force is acting on the turbine blades. Okay, due to that impulsive force, it pushes the blades to rotate. Okay, so the kinetic energy of the water get converted into mechanical energy due to rotation of the rotor, and this rotor is connected to the shaft. This shaft is also starts rotating, and this shaft in turn is connected to the electrical generator. In that generator, initially the magnetic field is present. As soon as the shaft starts rotating, so the generator breaks down its magnetic field. Okay, the generator it breaks down its magnetic field, and the movement of the electrons will be takes place. That movement of electrons we can term it as the electric current. So when the shaft starts rotating, it drives the electrical generator and it can produce the electrical energy. After performing that, the water will be discharged through the tail race. Okay, that is the working principle of the Pelton wheel. Okay, initially the water from the reservoir is enters into the nozzle through the penstock. Okay, in that nozzle the potential energy of the water get converted into kinetic energy. Okay, so the high velocity jet of water will be coming out from the nozzle that made to flow over the turbine blades. That high velocity jet of water, when it strikes tangentially in the buckets, at that time the impulsive force will be acting. That impulsive force that pushes the buckets to rotate. These buckets are attached to the runner. The runner also starts rotating. So the kinetic energy of the water get converted into mechanical energy. So once the rotator starts rotating, that rotor is connected to the shaft is also starts rotating. By utilizing that mechanical energy, we can run the generator and we can produce the electrical energy. After performing, the water will be discharged into the tail race. Okay, so the Pelton wheel, it is a tangential flow. The water striking the runner blades into the tangential direction, and the kinetic energy is available at the inlet of the turbine. Okay, and it is a high head turbine. The head available at the inlet is greater than the 150 meters. So the Pelton wheel, it is a tangential flow, high head impulse water turbine. Okay. Next, coming to the Francis turbine. Francis turbine, it is a medium head reaction water turbine. Okay, and both potential and kinetic energy is available at the inlet of the turbine. Okay, the Francis turbine, it is a medium head reaction water turbine. Okay, and it is a radial flow turbine. The water striking the runner blades in the radial direction. Radial direction is nothing but the perpendicular to the axis of the rotation of the runner. Okay, the water striking the runner blades in the radial direction. So the Francis turbine is a radial flow reaction water turbine, and it requires the medium head and medium quantity of the water to run the turbine. Okay, this Francis turbine, it consists of the main components are there is the spiral casing. Okay, and then guide wheel and guide blade. This is the guide wheel and guide blade, and then the draft tube. Okay, these are the main components of the Francis turbine. The spiral casing. Spiral casing nothing but it is a closed passage having the decreasing cross sectional area. You can see here the cross sectional area of the spiral casing is gradually decreasing along the flow direction. Okay, the spiral casing, it is a closed passage having decreasing cross sectional area along the flow direction. The main function of the spiral casing is for uniform distribution of the water over the runner blade. For uniform distribution of the water over the runner blades, the spiral casing is used. Okay, here in that Pelton wheel there is a nozzle is present to convert that potential energy of the water into kinetic energy, but here the nozzle is absent, but the spiral casing is designed in such a way that some part of potential energy get converted into kinetic energy. Okay, here the spiral casing, it acts as a nozzle. Okay, next guide wheel and guide blades. Okay, guide wheel, it is a circular wheel or stationary wheel, and the number of blades will be fixed on the circumference of the single wheel. That wheel we can call it as the guide wheel. Okay, so the number of these are the guide blades or stationary blades that will be fixed on the stationary wheel. Okay, this guide blade, the name itself is just guiding. It guides the water to flow over the runner blade in the radial direction. It gives the direction to the water to flow over the runner blade in the radial direction. Next, draft tube. Draft tube is nothing but it is a pipe or passage. It will be connected to the center of the shaft. This draft tube is used to discharge the water from the turbine to the tail race. Okay, through the draft tube the water will be discharging from the turbine to the tail race. Okay, these are the main components used in the Francis turbine. One is the spiral casing, guide wheel and guide blades, and then the draft tube. Spiral casing nothing but it is a passage. It is a closed passage having gradually decreasing area for uniform distribution of the water over the runner blades. Okay, and the guide blade and guide blades. Guide blade and guide blades are the stationary wheel and stationary blades. It just guides the water to flow over the runner blades in the radial direction. Next, this guide blades is placed around the runner, and these are the runner blades, and this runner is connected to the shaft. Okay, and this shaft is connected to the electrical generator. Okay, coming to the working. Initially the water from the reservoir is entered into the spiral casing through the penstock. Okay, the water from the reservoir is enters into the spiral casing through the penstock. In that spiral casing, the part of potential energy get converted into kinetic energy, because the spiral casing is designed in such a way that the cross sectional area of the spiral casing is gradually decreasing. Okay, so the part of potential energy of the water get converted into kinetic energy. Okay, after that the water enters into the guide blades, and this guide blades is guide the water to flow over the runner blades. Okay, when the water strikes the runner blades, the remaining part of potential energy get converted into kinetic energy. Okay, when the water strikes the runner blades through the guide blades, at that time the remaining part of potential energy get converted into kinetic energy. This kinetic energy is set into rotation of the runner. So, and when the water leaves the runner blades at very high velocity, at that time the backward force will be developed in that runner. Okay, that backward force also set the runner to rotate. So the kinetic energy of that water get converted into mechanical energy due to rotation of the rotor, and that mechanical energy can be used to run the generator, and we can produce the electrical energy. After performing that, the water discharge through the draft tube into the tail race. Okay, that is the working principle of the Francis turbine. Okay, initially the water from the reservoir having high potential energy that will be enter into the spiral casing through the penstock. In that spiral casing, the part of potential energy get converted into kinetic energy. Okay, after that the water enters into the guide blades, and this guide blades will guide the water to flow over the runner blades in the radial direction. The water striking the runner blades in the radial direction. At that time the impulsive force will be acting on the runner blades. So this impulsive force set the runner to rotate. So the remaining part of potential energy get converted into kinetic energy. Okay, this kinetic energy is set the runner to rotate. Okay, and then the water when it leaves the runner blades, at that time the backward force will be developed. Okay, that backward force also rotates the runner. So the kinetic energy of that water get converted into mechanical energy due to rotation of the rotor, and this rotor is connected to the shaft. The shaft is also starts rotating. In this shaft is connected to the electrical generator. We can run the electrical generator and we can produce the electricity. After performing that, the water will be discharged through the draft tube into the tail race. Okay, in this Francis turbine, it is a radial flow, medium head and reaction water turbine. Radial flow means nothing but the water strikes the runner blades in the radial direction, and it is a reaction water turbine. Both impulsive and the reactive force will be acting on the blades. Okay, in the incoming water, the impulsive force is acting on the runner blades, and the for outgoing of that water at that time, the backward force will be developed. Okay, the combination of these two forces you can call it as reaction force. That reaction force is set the runner to rotate. Okay, when the runner starts rotating, that kinetic energy get converted into mechanical energy. So the Francis turbine is a radial flow reaction water turbine, and head available is around 50 to 150 meters. Okay. Next we will discuss the working principle of the Kaplan turbine. Okay, Kaplan turbine, it is a axial flow low head reaction water turbine. Okay, it is a axial flow low head reaction water turbine. Okay, axial flow is nothing but the water striking the runner blades in the axial direction. Axial is nothing but it is parallel to the axis of the rotation of the runner. Okay, the water striking the runner blades in the axial direction. Okay, and reaction, it is a reaction water turbine. Both impulsive and reactive force is acting on that blades. In the incoming water, the impulsive force is acting on the blades, and when it leaves the runner blade, that time the backward forces will be developed. Okay, the combination of these two forces you can call it as the reaction force. Okay, it is a so it is a reaction water turbine, and the head available at the inlet of the turbine is less than 30 meters. So the Kaplan turbine, it is a axial flow low head reaction water turbine, and the Kaplan turbine, it consists of, there is a spiral casing and the runner blade and guide blades. Okay, and then hub and then the draft tube. Okay, these are the main components used in the Kaplan turbine. The spiral casing is nothing but it is a closed passage having gradually decreasing area. It is a closed passage having gradually decreasing area. Okay, and this the okay, first component of the Kaplan turbine, that is a spiral casing. Spiral casing is nothing but it is a closed passage having gradually decreasing area, that is used for uniform distribution of the water on the runner blades. For uniform distribution of the water, the spiral casing will be designed in such a way that the cross sectional area will be gradually decreasing. Okay, and then there is a guide blade and guide wheels. The guide blade and guide wheels, the number of blades will be attached to the circumference of the single wheel. We can call it as the guide wheel, and these are the stationary wheel. Just it is used to guide the water to flow over the runner blade in the axial direction. In the Kaplan turbine, the guide blades are designed in such a way that the water striking the runner blade in the axial direction. Okay, axial nothing but it is parallel to the axis. Okay, this is the axis of the turbine, so the water strikes the axial blades in the axial direction. Okay, next components is the hub. Hub is nothing but it is the runner. Okay, the number of blades can be fixed on the circumference of that wheel. We can call it as the runner or hub. Okay, this hub is attached to the vertical shaft. Okay, the runner in the Kaplan turbine, the runner blades are looks like a resembles with the propeller of the turbine. Hence the Kaplan turbine, it is also called as the propeller turbine. And draft tube is nothing but the pipe is gradually increasing area. It is used to discharge the water from the runner blade to the tail race. Okay, these are the main components used in the Kaplan turbine. Working principle, initially the water from the reservoir enters into the spiral casing through the penstock. In that spiral casing, the part of potential energy get converted into kinetic energy. After that, the water enters into the guide blades. Okay, and these guide blades is guide the water to flow over the runner blades in the axial direction. The water strikes the runner blades in the axial direction. When it strikes the runner blades, at that time the remaining part of the potential energy get converted into kinetic energy. Okay, when the water strikes the runner blades in the axial direction, at that time the impulsive force is acting on the runner blades. At that time the runner starts rotating. So that kinetic energy of that water sets the runner to rotate. When the water leaves the runner blade, at that time the backward force will be developed. That force is also rotates the runner. Okay, so the kinetic energy of the water get converted into mechanical energy due to rotation of the rotor, and this rotor is connected to the shaft, and this shaft is coupled to the electrical generator. By utilizing that mechanical energy, we can drive the electrical generator and we can produce the electrical energy. After performing that, the water will be discharged through the draft tube into the tail race. In that Kaplan turbine, the L-shaped draft tube is used. Okay, draft tube is nothing but it is a pipe having gradually increasing area. It is used for discharging the water from the turbine to the tail race. Okay, so working in that Kaplan turbine, initially the water from the reservoir is enters into the turbine casing through the penstock in the, so the part of potential energy get converted into kinetic energy. Okay, and when the water enters into the guide blades, and these guide blades is guide the water to flow over the runner blades in the axial direction. The water strikes the runner blades in the axial direction or axially. At that time the impulsive force is acting on the runner blades. At that time the remaining part of potential energy get converted into kinetic energy. This kinetic energy set the runner to rotate, and then the water leaves the runner blades. When the water leaves the runner blades, at that time the backward force will be developed, the reactive force will be developed on the runner. That reactive force also sets the runner to rotate. Okay, so due to rotation of the rotor, the kinetic energy of the water get converted into mechanical energy, and that mechanical energy can be used to run the generator, and we can produce the electrical energy. So after doing that work, the water will be discharged through the tail race. Okay, these are the working principle of the Pelton wheel, Francis turbine and Kaplan turbine. Kaplan turbine, that is an axial flow, a mere low head reaction water turbine. Here both impulse and reactive force is acting on the runner blades, and both potential as well as kinetic energy is available at the inlet. In the Francis turbine, here the both potential and kinetic energy is available at the inlet of the turbine. Okay, so it is a reaction water turbine, and it is a radial flow reaction water turbine, and head available at the inlet is 50 to 150 meters. And Pelton wheel, it is a tangential flow impulse water turbine. Only the impulsive force is acting on the runner blades, so that's why it is a impulse water turbine. Okay, and head available at the inlet is greater than 150 meters. Okay, now we will know what are the difference between the Pelton wheel, Francis and Kaplan turbine. I told that the Pelton wheel, here the nozzle is present. Okay, in the inlet of the turbine, only the kinetic energy available. Okay, because in that nozzle the pressure decreases and velocity increases. The potential energy of the water get converted into kinetic energy in the Pelton wheel. Okay, here the nozzle is present. Here the spiral casing is present, because the spiral casing is designed like a nozzle. Okay, the cross sectional area of the spiral casing is gradually decreasing. Here also the nozzle is absent, but the spiral casing will be designed like a nozzle. Okay, so the first difference between the Pelton wheel, Francis and Kaplan turbine, in that Pelton wheel the nozzle is present, here the spiral casing is present, and Kaplan turbine the spiral casing is present. Next, the Pelton wheel, it is a tangential flow turbine. Okay, the water strikes the runner blades into the tangential direction. Okay, in the Francis turbine it is a radial flow turbine. The water strikes the runner blades in the radial direction, that means perpendicular to the axis of the rotation of the runner. Okay, Kaplan turbine, it is a axial flow turbine. The water strikes the runner blades into the axial direction. Next difference is here draft tube is absent, and here draft tube is present, and in the Kaplan turbine the L-shaped draft tube is present. Okay, and it is a high head turbine, the head available at the inlet is greater than 150 meters, and here this is the medium head turbine, the head available at the inlet is 150 to 150 meters, and here it is a low head turbine, the head available at the inlet is less than 30 meters. Okay, and here it is a impulse water turbine. Okay, only the impulsive force is acting on the runner blades, and Francis turbine it is reaction water turbine, and Kaplan turbine it is a reaction water turbine. Okay, and Pelton mill it requires the small quantity of water to run the turbine. Okay, here the medium quantity of the water is used to run the turbine, and here less quantity of water is used to run the turbine, but here the large quantity of water is required to run the turbine. Okay, these are the main difference between the Pelton wheel, Francis, and then the Kaplan turbine. Okay, in the next session we are going to discuss the pumps. Okay, thank you.